Hello, everybody from the Dystonia Network of Australia. My name is Dr. Daniel Corp from Deakin University, and I'm here to give you a little bit of an update on what we're doing here at Deakin in our work on Dystonia. I think that a lot of you might have heard already from Jordan Morrison-Ham about a clinical trial of brain stimulation in cervical dystonia that we're doing. So I'll give you a little bit of an update on where we're at with that, and also talk about some previous work that we've done that has led into this clinical trial here, and also some more work that we're doing in the future. The part of the reason that I'm giving you this update is because you've been so generous in funding us and giving us some additional funding that is really helping us in getting this work done with this clinical trial. So we just wanted to say thank you so much. We're really, really grateful for your support, and it really does help us. It's not easy to get this funding, and it's quite expensive with all the MRIs and personnel that we're trying to get us to fund to help us with this trial. So thank you very much, and hopefully this video places in context about where we're at and where we're going in the future with this research. If you're wondering who I am, I'll give you a very brief update or a brief overview of what I've done before and what's led me to this work in dystonia. As I mentioned, my name is Dr. Daniel Corp. I finished my PhD here in Australia at Deakin in 2016, and I really spent my PhD using brain stimulation, these techniques that we're using in this trial here on cervical dystonia. After that, I went and did a postdoctoral fellowship in Boston. And this is where I really started to look into dystonia and to pick up the expertise in neuroimaging. So the PhD and also the postdoc has given me this expertise in both neuroimaging and also brain stimulation. And that has really led to the method that I use, or the overall process that I use, which is to first use neuroimaging to try and localize the brain networks that are not functioning optimally, and then try and use brain stimulation to target these networks therapeutically. So when you have certain brain networks in whatever brain disorder you have, we've found that some of them are not firing enough, some of them are firing too much. And if we can figure out exactly where in the brain these networks are occurring, we can then try and change that brain activity. So that's exactly what we're trying to do with this clinical trial here at Deakin at the moment. We do this in other movement disorders as well, but my main focus is on dystonia, and we're definitely the most advanced in this process with dystonia at the moment. I think Jordan has already recorded a great video a few months ago giving a complete overview of this trial. So I won't go through it in too much detail, other than to give you a bit of an update about where we're at the moment. But Jordan, of course, is completing her PhD. She's nearly at the end of her PhD, and I'm her supervisor. So we're definitely doing this as a team here with a few other people who you might have also met. And what we're doing is giving 10 days of brain stimulation to see whether that can reduce people's symptoms of cervical dystonia. So it's a sham controlled or a placebo controlled trial. So we get you in, give you 10 sessions of this brain stimulation, which lasts for 40 seconds over a very particular part of the brain. And once you've done that, we get you back a few weeks later to do the other condition. So it'll either be the real or the sham, and we'll definitely hope that you won't know which is which, so we can compare the conditions and actually see whether the real brain stimulation is having an effect there. And we've got a little bit of funding to do this into next year as well. So Jordan will finish her PhD and then we'll continue to fund her next year. So, even though it is a really good amount of money and we're really over the moon to get this grant, it is quite expensive to do these things. And as probably a lot of you know, to hire personnel and then also the MRIs that we need to do are very costly as well. So we are really grateful to the funding that you've been able to support us with, and it really does help us in trying to see this out to the end of 2024. We started about 12 months ago after being delayed with COVID for probably about 18 months for a start. So in the last 12 months, we've tested 7 people, and it may seem I guess not slow, but I just want to get the message across that it's not a fast process with these clinical trials. And sometimes you may think, all right, well, why can't you test 20 people in a year, or why can't you get this done in 18 months? But it's a really lengthy process. And to place this in context, I was reading the other day one that lasted for 6 years, and they tested about 15 people. So we are doing really well with this, and 7 people in about 12 months of testing. When you think about all of the processes that need to be put in place beforehand, and the hurdles that we need to jump over, is really great going. And Jordan is really doing such a great job with this. And we're also really grateful for the people who have come in and participated in this trial as well, because recruiting people is often something that delays these things for a really long time. So there have been no adverse events, serious adverse events at the moment. So the trial is progressing really well, and as I mentioned, we'll continue this to the end of 2024. So I won't give too much more away about the trial, because we do want to maintain that integrity of the results, and we are blinded as well. So I really can't give you too much detail before we actually finish testing. So I'll build the suspense there and park that for the moment. But I will talk about some other work that we've done in the past and that we're also continuing on in the future as well. And this is really the technique that informed the clinical trial. So we are targeting, if I go back one slide, this is actually the precise brain region that we're targeting with this brain stimulation when you come in and do this trial. And this was informed from this neuroimaging technique called lesion network mapping. So I'll give a brief explanation about what lesion network mapping is, and then I'll show you some results from the past and also what we're doing in the future with this. So this has come about in about the last 7 or 8 years, this new technique of lesion network mapping, and it's informed on traditional lesion mapping, which I guess if you don't really know what a brain lesion is, you can use the example of somebody having a stroke. And if someone has a stroke and then directly after that stroke, they develop any sort of symptoms in any sort of neurological disorder at all, you can say, all right, well, that stroke was in the frontal cortex or wherever it was. So you can attribute cause to that part of the brain for that symptom. So this does happen in dystonia, and those lesions in the past have somewhat informed where we think dystonia is coming from. But there is a problem in that often these lesions occur in really different and disparate parts of the brain. So that means that it's really unclear. We don't know if it is occurring, the dystonia symptoms are occurring due to, the frontal part of the brain here, the back part of the brain, or the temporal lobe part of the brain here that's shown. So this makes the localization really unclear as to where we might want to stimulate with a potential therapy like brain stimulation. So what lesion network mapping does is that it doesn't just look at the lesion location, but it actually maps the connections of all of these lesions within the brain. So then, even though we've got lesions that occur in many different parts of the brain, we can say, all right, well, that's completely fine. Now show me what they're all connected to. So it's not just using now the discrete anatomical location of the lesion, it's also using that connectivity information. So we did this in 2019, and we found that you can see on the left here that although these lesions do in fact occur in many different parts of the brain, they were all connected to these two specific parts of the brain, one in the cerebellum, a brain area at the back of your brain, the base of your brain, and the other is on the surface of the brain in your sensory cortex. And this is the part of the brain that really excited us, because we can then say, all right, we can target this with non-invasive stimulation, which I'll talk about a little bit later on, the rationale for that. But basically, it's reachable with this technique. We don't have to use a technique called deep brain stimulation, which targets deeper parts of the brain, subcortical parts of the brain. We then went and did a deep dive into every single lesion that has caused dystonia, and we found 359 cases. So we went through and did a lot of accounting about these brain lesions and tried to figure out what are the co-occurring symptoms, where do the lesions generally occur? Are there other movement disorders? Are there other symptoms like tremor? And I should mention, sorry, that this is in every single type of dystonia, while the previous study was only in cervical dystonia. So this was a prelude to the study that is coming up next that I'll show you, where we're doing lesion network mapping in every single type of dystonia, extending that work that we previously have done in cervical dystonia. What this showed, I won't go through the technicalities of the graph here too much, but we're really looking at the relationships between lesion location and the body part that is affected by dystonia. And the main thing that came out of this study that we published last year was that different types of dystonia are caused by different lesions to different brain regions. So this has then informed the next study that we're going to do, where we're going to do lesion network mapping in every type of dystonia, extending on that previous work. And earlier this year, we got a grant for $190,000 US from the Dystonia Medical Research Foundation. So we'll be doing this into 2024 and 2025. And why this is really great is that, like I mentioned, the trial that we're doing at the moment was informed by this work, by this lesion network mapping work. So we think of this not just as something that is abstract and, can possibly help us 20 years, 30 years in the future, or, looking at methods sort of work. We're really trying to translate this work into therapies. We're doing the best that we can at the moment to have our research be translatable. So if we can localize similar networks, our aim is to then again start trials in different types of dystonia as well, as we're doing with cervical dystonia right now. We've done already some prelim work in this, so we haven't mapped all of the lesions, but we have localized a pretty distinct brain network in dystonia, which we call a core brain network. And you can see that, so there are some commonalities between all of the different types of dystonia. So regardless of whether you have a dystonia to your hand, to your, cervical dystonia, to your foot, there do seem to be common regions. But they also do have, I guess, differences as well. And that's what we show here. So even though they tend to occur in certain brain regions, they also can affect slightly different subnetworks of these brain regions as well. As I mentioned, this is very prelim, so we still have a lot of work to do with this. But like I mentioned before, if you look at these regions in the previous slide, you'll see that these are all in deeper parts of the brain. So these can only be accessed if you want to stimulate them through brain stimulation, through deep brain stimulation. If we do what we're doing with the current trial, we can only stimulate through the scalp. So that is only what's called non-invasive stimulation. So we actually can't reach these deeper parts of the brain. But why we're really excited by these prelim results is that they are also showing up on the surface of the brain. There are certain results that we're finding in certain types of dystonia that are localizing these what are called cortical regions on the surface of the brain. So this is what we did previously in cervical dystonia, and they are also showing up, even though they're slightly different brain regions, they're also reachable with this non-invasive brain stimulation. So like I mentioned, this is exactly what we want to find, because our aim is to translate these findings into therapies and, conduct these future clinical trials using this type of brain stimulation. So other people can also use deep brain stimulation, but here at Deakin, we've got a whole lab set up, and you probably know that, some of you, because you've come in and generously participated in our trial. But yeah, we're really looking for these cortical parts of the brain. So these findings are really cool at the moment. In summary, thank you very much for your support. It really does make a big difference. And, it's been really great to speak with some of you who we've met already, and to really keep working collaboratively with you. Our aim going forward is to identify the networks of the brain not functioning optimally in dystonia. We do this using brain lesions because we have that causal information. So that's why this is a really cool technique, is because in neuroimaging in general, and in the past 20 or 30 years, it doesn't involve this causal information where you have a brain lesion like a stroke, and then after that, you get dystonia symptoms or other movement disorder symptoms. So that's why this is a really impactful technique. We then try and translate these findings into new therapies using non-invasive brain stimulation. So Please do contact me if you have any questions about anything that I've spoken about. I know it's probably a lot of information that I'm throwing at you here, so do please feel free to contact me. And also a little plug for our trial here. We are continuing this into the end of 2024. So we're always looking for people who have cervical dystonia to come in and participate in our trial. Okay, thank you very much. And I look forward to perhaps meeting some more of you. In closing, just thank you very much again. And I hope this video has been really helpful. Thank you.